Hello and welcome at AI Home Lab. Today I want to show you what we've been working on for the last 1.5 or 2 months. We've created our next level AI Home Lab with 228 gigabytes of VRAM. This is more a bit of a tinkerer movie where we show you how we built the whole thing and what went into it, what thinking steps went into creating that whole system. It's not about benchmarks, it's more about what steps do you need to take if you want to create something like that. So if you're into that, let's get ready and start. We used a Digitus 16U case. This is a server case, but not for computer components normally, but rather for internet or web components. We've placed that on inline skates wheels onto a wooden plate and then started to change everything on the insides. So this is what we are going to talk about right now. We have 1, 2, 3, 4 levels. On the first level, we have a motherboard and our PSU. Second level, we have graphics cards, SSDs, and another PSU. Third level, graphics cards. Fourth level, graphics card and a PSU. So now I'm going to explain all those parts that went into that. The first level, we used our old motherboard. It's a Gigabyte MZ01 CEO with 8 times 64 gigabytes of DDR4 ECC RAM. And we've also used the AMD 7551P CPU out of our last build. Now, this motherboard only comes with 4 full PCIe 16 lanes slots. So in theory, you can also only fit 4 GPUs. But we've used a bifurcation card, which splits those 16 lanes into 4 lanes. And with that, we can fit a lot more GPUs in here. And we've fitted 11 in here. Now, one thing you need to consider is, first of all, you need to activate this in your BIOS. And you need to make sure that your motherboard will support that. Now, one thing I would really recommend to you is, if you want to do something like that, go for server CPUs, because those will support more lanes. Consumer CPUs will only support around 16 to 24 lanes for the GPU. And then your consumer motherboard will perhaps support 16 more or 24 more, but that's that. So if you go for a server CPU, normally those will come with around 128 lanes, for instance. So that won't be a problem. And after that, you will also really need to make sure in your BIOS that you will activate your bifurcation settings. So for this one, X4, 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 X4. And then these will work. Also, one thing to consider is each PCIe slot will power your GPU with around 75 watts peak. Now, your GPU normally won't pull 75 watts. Mine here pull maximum around 40 watts, but most pull less than that. But that one will only support 75 watts. So this is what those two SATA ports are for. Each of those can, in theory, get you another 54 watts additional power. But it's important to plug those into one power cable each. So one power cable going to the PSU and another power cable going to the PSU. Don't daisy chain those, because they will start to melt. And this is also something that one viewer of mine pointed out. And this is kind of important. So make sure to use 2 different cables for your SATA ports here, and then you will be fine, or mostly you will be fine. Yeah, these are great, and this is what we use. So each GPU will only get 4 lanes. So we did cut our bandwidth a little bit, but that's fine for inference. Not for training, but for inference, that's fine. So if you want more lanes, just go for a motherboard with more PCIe slots. There are motherboards with 8 PCIe slots. Go for one of those if you want more lanes per GPU. Now the only GPU with more lanes in here is our RTX 3090 that gets 16 lanes because I could afford to do it like that. Now we connect all those GPUs with PCIe riser cables. The reason why we didn't go with normal USB risers is those only give you one lane, so that's not a lot. This is 4 gigabytes a second, so this isn't just not enough. And we have 4 lanes, so 16 gigabytes a second, which is a bit better. So this is why we went with those PCIe risers that are quite expensive, but give you a better bandwidth per GPU. Yeah. Now, on the first level, we also have our first PSU with 1500 watts, the Corsair one from our first build. That one will also support the motherboard and most of our bifurcation cards. For the bifurcation cards, take the strongest PSU and also take that one for the motherboard. It will just result in a more stable system, as I found out. Now, on the second level, we have our first line of GPUs, where we fitted 3 RTX 4060 Ti's and one 3060. So 3 times 16 gigabytes of VRAM and 1 times 12 gigabytes of VRAM. Now, these don't have a particularly great bandwidth. So if you want to train models, you will probably not want to go with these because bandwidth here isn't great. But we're not looking into training. We want to run models in inference, so that's fine. We also have 2 SSDs in here, a SATA SSD with 8 terabytes of storage and another SATA SSD with 1 terabyte storage and one M2 SSD with 2 terabytes of storage fitted onto the motherboard, so on chip. And we have our second PSU here that will also connect to many of those GPUs. Now, on the third level, we have 6 Nvidia P40s, which are still cooled by our 40mm fans, which are connected to an Arctic fan hub and a Noctua fan controller, 2 of those actually. And on the third level, we have our RTX 3090 and the last PSU with 1200 watts. Sorry about that. Now, if you counted, you could see that we have quite a lot of PSUs. All in all 3, one 1500 watts, one 1200 watts, and one 1250 watts. Now, it will never pull that much power, but I needed it just to make sure that I have enough 6+2 pin cables for all my GPUs, otherwise I wouldn't have had enough of those. In theory, the whole system could pull around 2800 watts, which is more than the standard power socket in Switzerland will provide. This is around 2500 watts, so it's 230 volts at 16 amperes. Now, I don't worry too much about that because like we're using GGUFs. And in GGUFs, you will only use one GPU at a time in a serial manner. So we never observed that much of a power draw. Now, if I would use VLLM, which I'm planning to, I'm probably going to need to make a cap for each of my GPUs to just bring the power down a little bit. Not by a lot, but a little bit. To make sure that we will never go above 2500 watts, which we can also measure and which we are planning to measure for VLLM. One thing you also need to consider if you build something like that is you don't have only one power supply, PSU, but here we have 3. So you need a 3 PSU adapter for your motherboard 24-pin connector. And this will make sure that all the PSUs understand when to start and what to do. I have a 2 PSU adapter here in my hand, but we have a 3 PSU adapter installed. Now, airflow-wise, we're working with a quite simple system. We have 8 120mm fans fitted onto the one side of our case and 8 120mm fans fitted onto the other side of our case. And here it pulls air in, and here it will get it out again. And we also cool our P40s individually. So those really never get above 60 degrees in usage, as far as I've seen it. None of those GPUs gets above that. Yeah. Now, as far as connectivity goes, we have made some small adjustments and 3D printed some I/O shields. Now, here we have two LAN sockets, two HDMI sockets, and two USB sockets, but I got another two USB sockets inside the case, which I can also use. And our power button and our audio out connected via a USB. Now for these, I only used male to female cables, which is an easy way to do this, and 3D printed some sockets to install it, which wasn't that difficult. So that was that. And if we have a look inside our case, you can see that we did a lot of things with wooden bases, with wooden plates. That's because my father is or has a carpenter company, and like they produce things out of wood, houses and everything like that. And now we used a combination of those wooden plates and some simple constructions to place the GPUs out of aluminium. Now for that, we used just a lot of screws, and yeah. If you want to do something like that, just be aware that you will need a lot of zippers, because otherwise, I think in American English and in English it's called zippers. Correct me if they are not called like that, sorry. In Switzerland, they are called Kabelbinder. So yeah, basically like cable bindings, whatever. If you want to do something like that, just be aware that you will need to do some cable management. Otherwise, you will have no airflow at all in your case. Now, if you are starting to boot your system, you will probably have problems at the beginning, because this is like a more complex system and it will take some time to find errors. In my case, I had problems with one power cable that belonged to another PSU, and I switched it up and it just wouldn't start like that. So that was one problem that I faced. I also faced some problems with GPU recognition when I started it up. So the thing that I changed is, if these GPUs get initialized, they can get initialized by one step or two steps in this with this motherboard. So I changed that to 2 steps, and this actually helped. Right now I have no more problems with GPU recognition. And one thing that you will also need to consider with a build like that is drivers. I personally installed the studio drivers once, and I tried it with that. That didn't work out great because I had troubles with the P40s. And then I tried to first install the Tesla drivers for the P40 and afterwards the studio driver, which also resulted in some problems. And I ended up only installing the Tesla drivers, and the other cards, they just work fine. So I had no problem with that. The Tesla drivers seem to also support the other cards, so that's fine. I use Windows, but you can also use Linux as well. That doesn't matter too much. Yeah, that's the whole build. Now, cost-wise, this build is around, or will cost you around 6,000 Swiss francs. I think that's around 6,800 US dollars. So it's quite expensive. I'm not sure if I would propose to everybody to build this thing. I think it's an interesting project. And for our case, it's working great because we can test bigger models. But on the other side, there are probably better solutions if you want to get a fast inference for cheap, or not cheap, but cheaper. I probably would not anymore go with P40s. These are okay if you're planning to go with 70B or perhaps 90B models, but okay means like 4 or 5 tokens a second. If you want to get above that, you really need to go for a 3090 or a 4090. Our 3060 Ti's, maybe. I want to test them some more. But just be aware that those don't have tensor cores, and this is kind of a problem. And this is also why the official branch of VLLM won't support the P40s. So there is a branch for the P40s, which I'm planning to test for that system, because it should speed up things quite a bit. But those aren't supported anymore by VLLM. Now, unfortunately, the V100 GPUs are still quite expensive, so that's not really an alternative. Andreas is going to test another alternative that we have looked at from AMD, but it works on ROCm, so we haven't like a lot of experience with that, but we're going to look into that. Yeah. Now, the system is still a bit loud. It's not quiet, and I will show you that in a minute. So if you're looking for a solution that is whisper quiet, this is not it. If you want a solution that is quiet, you need to use another solution for cooling, because this won't get you a whisper quiet solution for cooling. But just to get you a sense of how loud this can be, it's not incredibly loud, as you can hear, but it's also not whisper quiet. So probably not something you want in an office space, but it works fine. Now, with that said, thank you very much for watching that video. And in the next ones, we're going to test our build and are going to have a look at what we can do with it. And I'm also looking into VLLM because I really want to let that run here. Thank you very much for watching, and if you liked that video, please don't forget to like and subscribe and perhaps share, and I'm looking forward to see you in the next one.
Turning wires into dreams, building blocks of air and cold from beneath the surface scenes where imagination flows, chasing benchmarks, crafting AI pieces, so tuning algorithms, always reaching for more. AI gold map light up the screen, every bifurcation and every guess a dream, innovate, create from the ground up, high in the heart of machines under the open sky. In the lab with circuits hard, my artistic F5, every breakthrough made, bring the future to life. Pushing boundaries, vision, units, typing, pride, passion meets precision in this digital time. AI won't lab ignite the core, limitless potential, pushing ever more, educated faith with every probe we try in a symphony of progress, reaching for the sky. In the lava dreams where vision not there explain, breaking through the norm in a groundbreaking way. From keeping up to seriously data and the sound with passion, resolved to new heights for bound. Every lick of neon, tested in the AI home lab where direction instincts with the future development, doing both quality low revenue of the best ready to go explore. AI home lab light up the